What's up, everyone? This is Nate Morris, MasterLSAT.com. In this video, we're going to master the second logic game from the May 2020 LSAT-Flex. So if you haven't already taken that test, follow the link in the description below, try it first on your own, and then we'll master all the questions that you had trouble with together. And you can use the timestamps below to jump in between the questions. Okay, let's go ahead and look at game number 2 from the May 2020 LSAT-Flex. We have 6 coworkers. F, G, H, J, L, M. It looks as if those are our 6 variables in this game. So let's go ahead and, as we always do, write them out at the top of the page for reference. It says they are planning to play table tennis, and there will be 3 games, each involving 2 out of these 6 people. And each person will go into exactly 1 game. So it sounds as if we are sorting them out into groups, right? The 3 games are the 3 groups. So we are going to start off, as we always do in grouping games, by writing out the group headers. In this case, game 1, game 2, game 3. And it tells us that each involves 2 out of the 6 people, which means there are 2 people, 2 variables in each group. So that's nice. The numbers line up quite nicely. 6 variables, 3 groups, 2 in each group. Perfect. Let's go ahead and look at the rules. It says the 3 games take place one after the other, right? Game 1, game 2, game 3, let's say, in that order. So the following conditions govern. First of all, neither Faye nor Gary are allowed to play in the first game. So since we have a rule about the first game, we are going to write it under the header for the first game. F is not allowed to go into group 1, nor is G. And a similar rule is rule number 2. Neither J or L are allowed in the third one. Next, F has to go against either G or H. So one of the games has to be F. We don't know which group, so we have to write this off to the side. One of them has to be F with either G or H. So that's how we show 2 variables having to go together in a group. Of course, we don't know whether it's G or H, so we write G/H. And then finally, G is not allowed to go against J, so that's another rule. This applies to all the groups, so again, we show it off to the side. It doesn't apply to any one group in specific. And of course, we exit out. G is not allowed to go in the same group as J, which could have only happened in group 2 anyway, because group 1 can't have G and group 3 can't have J, so this is basically only applying to group 2 anyway. But we'll write it off to the side, since that's how normally we would write this rule type out. Anyway, this is the setup for this game. Let's go ahead and box this off as we always do and go ahead and attack the questions. Number 6 is, of course, a trustee acceptability question. We're just supposed to look through the rules to see which one follows all of them. So let's start with this rule over here. Group 1 cannot have F or G. A, I see F is in the first of the 3 games, so that's out. B follows that rule. F and G are not in the first game. C, also F and G are not in the first game. D, F and G are not in the first game. And finally, E, the first game does not include F and G, right? It's Luis against Martha in E. And so therefore, none of these other answers break that rule. Let's jump to this rule. J and L can't go in the final game. We'll start with B because A is already out. In B, the last of the 3 games includes Luis in B, therefore B is out, breaks that rule. C, the last game does not include J or L. D, the last game does not include J or L. E, the last game does not include J or L, so we are left with C, D, and E. Let's look for this rule. F has to go with G or H. We only have 3 answer choices left, C, D, and E. In C, F does not go with G or H, right? Faye goes against Jasmine, and therefore C breaks that rule. In D, F goes against G, so that's good. In E, F goes against H, so that's also good. And finally, G cannot go against J. In D, Gary does not go against Jasmine. In E, Gary does go in the same game as Jasmine, therefore E breaks that final rule, and we are left with D, of course, as the answer. Nice and easy. Number 7, if Martha is in the third game, so without even thinking, we make that if true, we draw the groups out, we put M in the third game, and we start to look for inferences. So what do we know If M goes in the third game, let's look at the rules and see what we know for sure. Well, we have a rule that says F has to go with G or H, which means that can no longer happen in the third game because M is already there. And it can never happen in the first game because a rule about the first game tells us that F never goes there. And therefore, F, along with G or H, must only go in group 2, right? It can't fit in group 3 anymore, and it can never go in group 1. Okay, so that's going to be game number 2. What about game number 3? Who can go with M there? We are very limited because J and L are not allowed to go there. F is already elsewhere. So if it's not J, L, or F, right, it's important to be good at keeping track of the letters and kind of using process of elimination. When you're trying to fill up a certain spot, in this case, this spot, ask yourself who's left that could possibly go there. If it's not J, L, or F, that only leaves 2 other letters, namely G and H, right? And that's very significant because now we know that whichever of the G or H goes into group 2, the other one has to go in group 3, right? We have G/H in 2 and G/H in 3, which means whatever 2 letters are left must go into group 1. In this case, that is L and J. Those are the only 2 letters left, right? Since G and H are taken up by groups 2 and 3, we don't know which one goes where, but we know one of them goes into 2 and one of them goes into 3. That leaves L and J for group 1. So we figured everything out here. The question says, who must Luis play against? And the answer is J. We just figured that out, right? The answer is D, Jasmine, right? We just proved that L has to go with J. And in fact, L cannot go against A, B, C, or E. Faye, Gary, Henry, or Martha. And therefore, that proves that D is the answer. Nice and easy. Number 8, if Jasmine goes into the second group, which of the following could be one of the 3 games? So, as always, without even thinking, we go ahead and make the if true. We draw out the groups and we put Jasmine into the second game. And we look at the rules and see if there are any inferences, anything that is forced by this scenario. Well, a good place to start is, what else do we know about J? Well, we know that J can never go with G, right? So therefore, G is not going to be allowed into group 2 in this case. But wait a second. From looking at the other rules, we know that G is also never allowed into group number 1, which means if G is not going into 1 ever, and if G is not going into 2 in this particular question, that forces G by process of elimination to go into group 3. So that's our first inference. Now, let's look at the other rules. We have another rule that involves G, right? It's always good to follow the following dominoes, right? Once we set one inference into effect, let's see if that triggers another one. So we just forced G somewhere. And we have a rule that says that G is one of 2 possible things that has to go with F, right? And if we look carefully here, we see that in this case, G must go with F, because what's the only other option is for F to go with H. And the only place that that could have possibly happened would be over there. But that would break this rule. F is never allowed into group 1, right? Which means that you cannot do that here. You cannot put F with H, right? Because F with H wouldn't fit into groups 2 or 3 anymore, and it couldn't go into group 1 ever because F is never allowed in group 1, which means F must go with G. So we can actually go ahead and know that F accompanies G in that third group. So it seems as if this is all of the inferences. Let's go ahead and look at the answers, see if we can find one that could be true. A, clearly F cannot go against Henry, or B, against Martha for that matter, because F is going against Gary, as we just proved. F must go with G. So A and B are impossible. And C and D are also impossible. Gary cannot go against Lewis or Martha because, once again, Gary is going against Faye. And therefore, C and D are impossible. E is the correct answer. It's the only one that could be true. H could go against L. That could happen in this first group. And of course, that would leave M to go in the middle group, and that would follow all the rules, and therefore E could be true. Now, even if you didn't see that final inference that we saw before, remember we saw that F had to go into group 3, that was kind of a tricky inference, but let's rewind a little bit. Even if we didn't see that tricky inference, we could still answer this question extremely quickly because it's clear that A is impossible, right? Even from knowing what we know right now up on the page, which is that J is in 2 and of course G is in 3, that was the easier inference. We can see that A is impossible. We can't put F with H because that would have to go in group 1, and F can never go in group 1. Same thing with B. F against Martha would have to go in group 1. It couldn't fit in 2 or 3. and F never goes in group 1. C, Gary against Lewis couldn't work because Lewis never goes into group 3, right? That wouldn't work. So therefore, that's not the answer. D, Gary against Martha, we would see right away wouldn't work because that would force F to go with H, because either G or H has to go with F. In this case, it wouldn't be G. F, it would have to be over there. And as we've already pointed out, that doesn't work because F is not allowed into group 1. So either way, as long as you do this question correctly, even if you don't see that tricky inference, you'll still arrive at E being the answer, which is that H can go against Lewis in that first group, right? And M would go there, and F would go against G. Number 9, if F plays against Henry in one of the 3 games, which of the following is something that must be true? So as always, we start by making the if true. In this case, we can't put it into a group because we don't know, at least we don't know yet, what group that happens in. So we have to just write that up here as another rule to deal with for this question. And as always, let's look for inferences. Well, if F goes with H, it seems as if that could potentially go into groups 2 or 3, right? Obviously can't go into group 1 because F never goes in group 1 according to the rules. But it seems as if it has a couple of other options. But let's think about the letters that are left. We're left with 4 letters, right? G, J, L, and M. And of those 4 letters, G and J have a very specific relationship with each other, which is that they are not allowed to go together, which means that whatever order these go in, we don't know yet, but we do know that G and J are going to be separate and that L and M are going to be split up between G and J, right? We know that that is going to be the 3 groups. We just don't know which one is going to go where. Now, let's look at our group-related rules, or rules that relate to specific groups, to see if we can figure out any of these groups in terms of where they would have to go. So let's see. The first group cannot have F or G, which means it can't have this combination, and it also can't have this combination. Neither of these 2 things can go into group 1, which means we figured something out. We figured out that this third group has to go into group 1. J has to go along with L or M into group 1. And then it seems as if the other 2 have a little bit of wiggle room into the other 2 groups. But we do know definitively that J has to go with L or M into group 1. So let's look through the answers to see if we are done the question. Which of the following must be true? If we scan through here, A is not something we have determined, right? We don't know yet where Faye goes. B, we don't know yet where Henry goes. But C, we do know that Jasmine plays in the first game. We just determined that. And therefore, C must be true and is the correct answer. D, it looks like could be true, right? Luis could be in that first game, but it doesn't seem like Luis has to be in the first game. And E, we don't yet know whether Martha goes into the third game or not. The only thing we've determined here is C. Jasmine's in the first game, and therefore C is the answer. From following the inferences here, we proved that that had to be true. Number 10 asks us to tally up how many people could go into the second game. Of course, this doesn't mean at the same time, because obviously 2 people can only go in at the same time, but it's asking us how many of those 6 people could ever possibly go into the second game. The good news is we have a couple of scenarios on the page, so we don't have to do much work, because as you can see, we've already put a whole bunch of the letters into group 2 in different scenarios. For example, F could have been in group 2 as it was in number 7. Same thing with G or H, right? It could have been G or H. And in number 8, conveniently, 2 completely other letters, J and M, which means from scenarios on the page, we already know that at least 5 out of those 6 letters could go into the second game, F, G, H, J, and M. And therefore, right off the bat, the answer is either D or E. That's why it's always so important to leave scenarios on the page that worked in past questions, so that you can see, I put F into group 2, and it worked. I put either G or H, it could have been either one, into group 2, and it worked. And same thing with J and M. And therefore, the only question is the remaining letter, which is L. The only question is whether L works in group 2, and if it does, the answer is 6. If it doesn't, the answer is 5. So we have precisely one thing to test out for number 10, and that is, can we put L into group 2? Well, let's see. If we put L into group 2, let's first try to go ahead and place this F thing, because that's a little bit difficult to do, right? Because it can't go in group 1 ever. And in this case, it's not fitting into group 2. So let's go ahead and put F into group 3. right? We'll put it along with G, and that way we take care of that rule, and it gives us one less thing to worry about over here. We don't have to worry about keeping G out of 1 once we already put G into 3, so that's nice and convenient. And now, what are we left with? We're left with M and J and H. And it kind of seems as if they have a bunch of wiggle room, right? So let's say we put J over there, I don't know, M and H over there. It seems that we followed all the rules, right? We didn't break this rule. We certainly didn't break this rule. We made sure to follow this rule, and we certainly didn't put G and J together, and therefore we just proved that L could go into group 2. That was the one thing we had to do on this question because we've already put the other 5 letters into group 2, and therefore the answer is all 6 of them could be in group 2. The answer is E. Finally, number 11 is our dreaded rule substitution question. And this question asks us to find a substitution for the GJ rule. It asks us, what could we have told you instead of this rule that would have meant the exact same thing in the context of these other rules? Now, it's beyond the scope of this video to provide a detailed tutorial of this question type, right? We could spend an hour talking about rule substitution questions, so I'd highly advise you to check out my Logic Games tutorial videos where we essentially do that. We spend a lot of time thoroughly discussing rule substitution questions. For now, let's look for the intuition. Let's look for the tools that we would want to use to answer this specific question. You always want to think intuitively through these answer choices and ask yourself which ones are worth investigating, which ones make sense, which ones don't make sense, and depending on what rule substitution question you're doing on what game, it might require different tools to be used. So let's just talk about the tools that we would use to answer this specific question. Let's go ahead and look through the answer choices and ask ourselves which one of these things seems as if it means the same thing or might mean the same thing as telling me that G and J cannot go together. A lot of my students pick A on this question, but A is not the correct answer, right? A tells us if Henry's in the first group, then G has to be in the third group. Now, that is going to force G to not go with J, right? Because if G goes into the third game, we know that J never goes in the third game. So, of course, A will force the original rule to be true if Henry plays in the first game. The problem is, what if Henry doesn't play in the first game, right? If Henry doesn't play in the first game, then G could go anywhere, potentially with J, right? What if Henry doesn't go into that first game, right? What if Henry went into the third game, right? Then according to this rule, nothing is restricted. Gary could go anywhere. Gary could go with J. I could break that original rule by doing that, and I could put F with H, and I could follow all the other rules. I can put L and M over there. And of course, this would break the original rule, and yet it would follow A because A is not triggered. And therefore, this proves that A must not be the answer, right? Because there's a way to follow A but break the original rule. Now, let's skip B for now just because it's the right answer. I want to keep going on the wrong answers first. C says Jasmine has to be in the game immediately before Faye. Now, anything that we've made false in the past cannot mean the same thing as our rule that we're looking at, right? That's another shortcut, another tool that you have, is ask yourself, do I have any scenarios on the page where I've ever made one of these answer choices or some of these answer choices false in the past? That would prove that they don't mean the same thing as the original rule because we've always followed the original rule. And if we've ever made C false, that proves that C must mean something different than the original rule. And C says J has to be immediately before F. Now, it seems that we follow that on every scenario on the page that we have fully drawn out. However, if you go ahead and look back at number 6, remember number 6 counts also, right? The answer to number 6 was D. That was also a scenario that worked. And in that case, we see that J was not in the game immediately before F, right? J was in the first game in 6D, and F was in the third game. And therefore, that's something that we've made false, and we don't even need to test it out or investigate or think about it. So therefore, C cannot be the answer. What about D? J has to be immediately before G. Well, that we showed could be false on the page, namely over here in number 7, right? J was first, and G could have been third, which would have violated D, but of course, it followed the original rule, right? And therefore, how could those two statements mean the same thing? And then finally, E Telling me that Gary can't play against Lewis doesn't tell me that Gary can't play against Jasmine, right? Those are two different letters. L and J are different letters. Why would E mean the same thing as the original rule, right? According to the original rule, Gary is allowed to play against Lewis, even though we've never done that on the page. Why wouldn't that work? We could go ahead and put G and L in, let's say, the middle group, and then F would have to go with H over here, and we'd be left with M and J, and this works perfectly, right? So this proves that E is not forced by the original rule, because the original rule here was followed. We didn't put G with J, but we did put G with L, and therefore these are two different rules, and E doesn't mean the same thing. So that can't be the answer either. Now that leaves us with B. Let's think about the intuition, right? Because we always want to think about these questions as intuitively as possible. B says if J is in the second game, G has to be in the third game. Now, you may remember that I briefly mentioned when we were setting up this game that this GJ rule only matters in terms of the second group, because that's the only group that they could have possibly gone together in, right? Because G's never going into group 1 anyway. And J's never going into group 3 anyway. So the only group that could have possibly broken that rule is group 2, right? So essentially, if you tell me that G and J can't both go into group 2, that's telling me the same thing as telling me that they can't go together in any of the groups, right? And B is basically telling you, or it is literally telling you, that G and J cannot go into the second group. Because B, 11B, tells us that if Jasmine goes into the second game, Gary cannot go there. Gary must go in the third game. Now that makes sense because Gary anyway cannot go into the first game ever, right? So according to our original rule, this makes sense. If Jasmine went into the second game, then yes, Gary would have to go into the third game as a function of them not being allowed to go into the same group as each other. Right? So this follows from the original rule. And notice that this is telling us exactly what the original rule is telling us, which is that G and J cannot go together. This is telling you that they can't go together in that middle group, right? Because if Jasmine didn't play in the second game, then there would be no way to break this rule. Because the only way to break this rule would be to put G and J in the middle. So if one of those two letters was missing from that middle group, then there would be no way of breaking this rule because you couldn't put them together in group 1 because of that rule, and you couldn't put them together in group 3 because of that rule, right? And so therefore, B is telling us that if J is in the second game, G has to go elsewhere. And elsewhere is literally defined as group 3 because anyway, G could never go into group 1 because of that rule, right? So this is essentially telling you, or it is literally telling you exactly the same as our original rule. G and J cannot go together, right? It's saying that if J goes in the second game, G has to go elsewhere. If J doesn't go in the second game, then other rules are preventing G and J from going together in the other two groups anyway, right? So it's okay that this is a conditional rule based on that second group, right? And as we pointed out, but I'll point out one more time, it's not too restrictive to say that Gary has to go in the third game, because if J's in the second group, then telling me that G can't go with J is the same thing as telling me that G has to go in the third group, because once again, there's another rule that prevents G from going into the first group. And I know that these are always the trickiest questions, or they tend to be the trickiest questions, but if this is a little unclear, I encourage you to check out the Master LSAT tutorial videos for rule substitution questions, and they sort of come with practice, right? Hopefully, as long as you understood to some extent the intuition behind these answer choices on this particular question, and as long as you keep practicing and doing that for more and more logic games and more rule substitution questions, you will get better at them over time. At any rate, hopefully this made sense, and this marks the end of this logic game. If you found this video useful, don't forget to hit subscribe. And for thousands more clear LSAT explanation videos, go to masterlsat.com.